Welcome to the webinar series on Intel Higher Education Challenge. Today's webinar is on Intel Genuino Development Board, which is based on Intel Curie Compute Module. Let us go through the lessons that we are going to learn today. So in today's webinar, firstly, we will discuss the Intel Curie Compute Module. We will also talk about its key features and various benefits of Intel Curie. Then we will discuss Intel Genuino 101, which uses Intel Curie, a tiny module. Then we will talk about major applications of Intel Genuino 101 and how it could be beneficial to develop some really interesting stuff. So Intel Curie module is a very powerful tiny module which uses Intel Quark SoC, a 32-bit Intel architecture-based CPU running at 32 MHz of clock frequency. Other than this, Intel Curie also contains an ARC-based DSP processor. Curie module also includes a Bosch BMI 160 6-axis sensing device, Bluetooth Low Energy, and a pattern matching engine which uses 128 parallel arithmetic units, which is also called as processing elements. In addition to this, Curie also has got 384 kilobytes of flash, 80 kilobytes of SRAM. So we can say Intel Curie is a tiny module with endless opportunities. So we have already discussed the key features of Intel Curie module, which enables endless opportunities for innovators and developers. Some of the additional features of Intel Curie module are shown in the slide. It is a tiny device that can operate from a coin-sized battery. There is also a pattern matching engine which is capable of learning and recognizing patterns in arbitrary sets of data. Intel Curie is also packed with security features at hardware and firmware level that will help to protect the data and code running at the system. In this slide, we will talk about the Intel Genuino 101 that uses Intel Curie microcontroller. The 101 has some features in common with both Uno and Zero, which are 32-bit microcontrollers, but the low-power Intel microcontroller, onboard BLE, and motion sensors make it unique. Intel Curie is a very powerful device, and combining it with Arduino gives user a huge flexibility and support to develop applications. So Intel Genuino is an Intel architecture 32-bit based system with a huge vendor and peripheral support, and its association with Arduino enables users for rapid prototyping and opens gate for IoT application development. Its tiny size, low power BLE makes it a perfect for wearable devices. Let's have a glance on the features of Intel Genuino 101 board. It operates at 3.3 volts with a 5 volt tolerance, as Quark belongs to the low power series family, while it supports the 7 to 12 volts input DC voltage. It has 14 GPIOs, out of which 4 can be used to generate PWM signal. Intel Genuino also has an onboard ADC with 6 pins to connect analog sensors with the board, while DC current per input-output pin is 20 milliamperes. It features a 196 kilobytes flash memory and a 24 kilobytes SRAM and runs up to a clock frequency of 32 MHz. If we talk about the firmware support, it runs an Zephyr, an open source operating system. It has also got one USB module and a JTAG debugger. It features a 32-bit DSP sensor hub with 128 neural network node, which has 2 pattern recognition algorithms. One is k-nearest neighbor and the second one is radial basis function. In addition to this, it has also got 2 distance matching formulas, LSUP and L1, and constant recognition time, which makes it unique from all other boards. This board can be programmed using a simple Arduino IDE. The onboard peripherals enables the board to support a large class of applications. The 6-axis accelerometer enables it to measure speed, height, distance, airtime, rotation of object, and gravitational force. Some of the application areas where it could be very useful are like sports and fitness, where the Genuino can be embedded in the head of a golf club, measuring all aspects of golfer's swing, or embedded within a football, measuring the arc and spiral from a quarterback's throw, or in a skateboard, measuring kick flips and some other tricks. It could also be used in a shirt collar to provide feedback about a sit-up or a push-up. Similarly, in healthcare industry, it can be used to monitor elderly people if they fall, could be used to detect patient movement, and also for predictive diagnostics using pattern matching. It can also be used in civil engineering to find movement at bridge, earthquake detection, and other applications like pet monitoring and tracking cars movement using gyroscope. So now let us see how we can develop an Arduino application using Intel Genuino 101. So before starting, you need to make sure that you have the Arduino IDE installed, an Intel Genuino 101, a USB cable A to B, a DC adapter ranging from 7 to 12 volts, and a host machine running either Linux, Windows, or Mac OS. You can download and install the Arduino IDE using the links given in the slide for your machine. After installing the Arduino IDE, you need to install the software package for Intel Cuire Module. To install the same, go to the Boards Manager and search for the Intel Curie boards by Intel, and then click on Install. Then go to the Tools section and select the appropriate board, which is Arduino/Genuino 101 in this case. Once you have selected the board, then go to the Tools section again and select the appropriate COM port that can be found in the Device Manager. Here, in this case, COM15 is the desired COM port. Now there are some other points that you need to take care for learning the Arduino IDE. First one is, after writing the sketch, you need to save the sketch by using the save button icon. You can also verify the sketch to check if there are any errors in the code, and then use the upload button to dump the program in your board. You can also access the serial monitor, which is shown on the top right corner of the Arduino window. To access this serial monitor, your board should be connected to the laptop or the system that you are using. So after doing all these steps, now you can test your board with the very first and basic Arduino program that is called Blink. To open this program, go to the Files, then navigate to the Examples and search for the Blink program in the Basics section. There is one green color LED on the board which is connected with the digital pin number 13. Now verify the program to check if there is any error by clicking on the Verify button. Then upload the sketch on your board and observe if the LED is blinking on the board or not. This is how you will check the functioning of your Intel Genuino 101 and will get started with the application development part. For any further queries, you can contact us on mentor@fice.in. Thank you for listening to the webinar. Have a very nice day.